All right, so we're into projectile motion part 2. So our second example, which talks about a cannonball being shot from the top of a cliff. So let me read the specifics here. A cannonball is shot out of a cannon upwards with a horizontal velocity of 40 meters per second to the right and a vertical velocity of 20 meters per second up. If the cannon is sitting at the top of the cliff, that is 100 meters high, we get to A. How far right will the cannonball travel? All right, so before we get to A, I'm going to write down the information we actually know. So it says we have a cannon, and it's got a horizontal velocity of 40 meters per second to the right. So that would be our V1x is 40. So I'm going to put that in here again. You can see that I've got my variables here. I've got my two different sets of data, my horizontal components, my vertical components, and of course the bridge in the middle, the delta t. Now, what else we got here? It has a vertical velocity. So that would be our V1y of 20 meters per second. So I'm going to put that right here. All right, and the other thing is that this cliff, I'm going to write it down on my diagram, is 100 meters high. All right, so that's the information I've got so far. So I want to see, are there any other variables I can fill in before I even look at solving for part A. And so I don't know the final horizontal velocity, not yet anyways. AX. So again, this is looking at horizontally. Is this cannonball being pushed to the right even further, or is it being slowed down by anything? And again, we're in a perfect world, so there's no air resistance. And so the acceleration in the horizontal plane is 0, which means then your velocity is not changing. So if it's 40 meters per second horizontally, in the end, it's also going to be 40 meters per second. What else we got here? So delta t, I don't know how long anything's going on here. AY, the acceleration. Again, we have some gravity going on. So it's negative 9.8, which means that our final velocity in the vertical direction will change. So that's just what I know so far from the question. Now we get to actually figuring something out. So what do we got here? It says, how far right will the cannonball travel? So, right, we're in our horizontal components here. And so in A, I don't know that. Now, here's what I do know is that I am looking for this delta x here. All right, so that's the distance. I want to know how far away from the cliff this cannonball lands. Now, something I do know that when this cannonball is getting shot from the top of the cannon is that in the end, it's going to be dropping below the cliff. And in fact, that means our delta y, whoops, I should put A here because is negative 100. Because in fact, it's going to be much lower than its original position horizontally. All right, so there's our information. Now let's check it out. So I go to my formula sheet. I want my delta x, which again looks like a delta d on my formula sheet. And let's see here. First equation, not happening. There isn't even a delta d. Second equation, there is a delta d. We need a vi, got it. Need a delta t. Don't have that. All right, third equation, delta d, I got it. Missing delta t again, okay. Let me see. Fourth equation, it's always been a winner. Delta d we got. Acceleration we got. VI, VF. Okay, now here's the problem with this fourth equation. The VF squared equals VI squared is that when our acceleration is 0, what this equation will simplify down to, unfortunately for us, is VF squared equals V1 squared, which we already know that they're equal. So that fourth equation, we can substitute in. It doesn't tell us anything because the acceleration is 0. It doesn't have for us. Now I get to the last equation, 1, 2, 3, the fifth one. It's got a delta d in it. We need a VF, got it. We need a delta t again. So none of these equations will work. So because we're missing variables, so I'm going to have to do a little bit of a step here. I got to find out more information because none of these formulas are going to work for me. I do not have enough information. And that now is where we're going to use our bridge, our delta t. So I'm going to go down here to my vertical components, see if I can use them to find delta t. Then I can come back up here and find my delta x. So I'm going to have to work with my vertical components to figure out this bridge so that I can get my delta x. All right, so now we're down the verticals. I want to find delta t because that's my bridge. I need that. So again, I'm looking at the first equation. It's got delta t. It's got an a in it. We're missing vf. Okay. Second equation. Delta t is in it. We need a delta d. Got it. Vi, we got it. A, we got it. Perfect. So we're going to use the second equation. All right, so I'm going to write that down, the second equation, where we have, and again, converting it into its component form, where I have a delta y is equal to a v1y times delta t plus 1/2 a y delta t squared. All right, so there it is. There's my formula. And so now I'm going to substitute in my values. So my delta y is minus 100. All right, my v1y, oh good, it's 20. Nice round number for me. 20 times delta t. Again, plus 1/2, convert that half to a decimal. My ay is a negative 9.8. And we have a delta t squared. All right, so I'm just going to simplify this now. And so let's see here. I got negative 100 equals 20 delta t. A half times negative 9.9 is a negative 4.9 delta t squared. All right, now, here's the problem with this one. We had this at our 9 o'clock class in our first example. I have delta t. I want to solve for it, but I also have a delta t squared there. I got myself a quadratic equation. And so to solve the quadratic equation, I have to have a 0 on one side of the equation. So the easiest thing is I can move that negative 100 over to the other side. All right, so I'm going to move that negative 100 over to the other side. Now, because I have a quadratic equation, I want to write it in order, where I have my squared term first, my normal term next, and then my number last. So this minus 4.9 delta t squared, I'm going to write that first. All right, then I'm going to write my positive 20 delta t. And again, as I mentioned, I'm bringing the negative 100 over, so it becomes a positive 100. Now, in this morning's example, I was able to solve this by factoring in a delta t. Unfortunately, that's not going to happen because I have 3 terms this time, and so I'm going to have to use the quadratic formula, where your a is your number in front of your delta t squared, your b is the number in front of delta t, and your c is, well, just your number. All right, so hopefully we can fit this all in. So here we go. Delta t is equal to negative b. Well, b is 20, so I'm going to have a negative 20, plus or minus the square root of b squared minus 4ac underneath the square root sign there. So b squared is 20 squared plus 4 times a times c. And of course, I can't forget that this is all going to be divided by 2a, which is 2 times negative 4.9. All right. So again, I got to simplify this. All right, so I got delta t is equal to negative 20 plus or minus. All right, now I get under the square root sign. 20 squared. Well, 20 times 20 is 400. Now, this is where I find a lot of students mess up the quadratic formula. I teach a lot of math too, is getting the sign right for the second part underneath the square root sign. And what I do is I just look at, I got a positive 4 times a negative 4.9 times a 100, positive 100. So I have a positive times a negative, which gives me a negative. Negative times a positive, it's going to give me a negative. And so when I multiply my 3 numbers, let's see here. I know it's going to be negative. I get, what am I missing there? 20 squared minus 4.9, 4 times A times C, 1960. What am I? B squared minus 4AC. Jeepers. So it actually is going to be positive. What was I doing there? Got my quadratic formula wrong. B squared minus 4AC, not plus 4AC. So again, negative times a negative gives you a positive. Times a positive gives you a positive. All right, and again, that's going to be divided by 2 times negative 4.9, which is a negative 9.8. All right, so again, further simplifying the quadratic formula here, I end up with negative 20 plus or minus, and it's going to be divided by negative 9.8. And so I'm going to put 400 and 1960 together and then take the square roots. So let's see here, 400 plus 1960 equals that. Square root that number, and I get 48.58. All right, now the other part that I find solving quadratic formula that people struggle with is the very end. The last thing you do is you divide by negative 9.8, because what a lot of people don't realize when you're doing math is that when you have a fraction, essentially the top and the bottom are brackets, which means, Bedmas, I got to do the top first and then do the divide by negative 9.8. So I'm going to take my minus 20 here, and I'm going to add 48.8, or 48.58, I should say. All right, then I get a number, and I'm going to divide it by negative 9.8. And I get, negative 2.92 is one answer. And, of course, I get another answer, which is, let me see, I take my negative 20, I subtract 48.58, and then I divide it by negative 9.8. So what do I end up with this time? All right, survey says, then we get, I actually get, if I round to 2 decimal places, 7 seconds. All right, now, what I'm looking at here is, I've got 2 times where this cannonball lands. Well, that's not possible. The cannonball only lands 1 time. And so when I look at negative 9.2 or negative 2.92 seconds and 7 seconds, well, which one is it? You cannot have negative time. And again, I want to stress this is when you're writing a test, if you're in math or anything, you're getting rid of an answer, you have to tell me why. And the reason I'm getting rid of this one is can't have negative time. And so our answer, or when this ball lands, I should put this for A. Well, that's actually the whole question anyways. So I got my 7.0 seconds there down for delta t. All right, so I've got my delta t and my bridge. But we're not done yet. That's not what we're trying to find. The time when it lands, we want to find out how far right when it lands. All right, so I'm going to get rid of this. We don't need this anymore. A little bit of work there using the old quadratic formula. Again, a little bit of review of grade 10 math, trigonometry, quadratic formula. Hopefully you took grade 10 math over there. All right, so now continuing on. Hey, I got my delta t now. So now I'm going to go back to my formula sheet because originally I want to find out how far right this thing went. So now I'm armed with my delta t. See if I can figure things out here. My first equation. I'm looking for a delta d. I don't even have it in the first equation. Now we got, what about our second equation? Delta d, or delta x, I should say. We got, we're looking for, delta d's in there. We need a vi, got it. Delta t, I got that now. Acceleration, I got it. Delta t, I got it. Perfect. So I'm going to use my second equation, all right, which is, again, writing in terms of components, delta x is equal to v1x times delta t plus 1/2 ax delta t squared. All right, so I'm going to sub my values in.
Mr. Gate.
Yes.
A bunch of the students and I find it very glitchy, and we can't read the board.
Can't read the board?
No, it's very blurry.
Blurry, eh? Okay. How long has that been going on for?
Um, I've noticed it since the end of the last question.
Okay.
But yeah.
So let me see here. Yeah, I see what you guys are seeing. All right, so what I'm gonna have to do is commit or leave and then come back, okay? So I'll do that real quick. That's the only way I found that works. So here we go.